just talk about, but it's worth mentioning, heap overflows are also a problem in C. So here I use malloc to reserve some space on the heap for some characters with room for 20. And so when you do that again, you can put in, it's going to take name 1 and name 2, so you can put in characters 20 A and B, and it'll understand them. But if you put in 40 characters, then it totally fouls them up. One of them has A's and B's and then something. The other one has B's. As they run into each other, just like the Stack Overflow. And again, this would not happen in Rust. It will just take as long as you want. It'll keep them separate, as it should. If you look at GDB, you'll see why. And there is another interesting feature about Rust. Notice in C, I allocate space, and here I just ended the program, but what you really ought to do is allocate it, and when you're done with it, you free it. In Rust, you don't have to do that. In Rust, when you define something with this box command, it only exists in its scope, which is from the curly brace here to the curly brace here. So when you leave scope, it automatically frees it. You do not manually free things. In C, there are serious problems from dangling pointers when you leave something and you fail to free it, or something you free something twice. Both of those lead to serious flaws. So here's a dangling pointer in C. I allocate something here with name 2, and then I use it again down here. I read into it after allocating it. Name 1 and name 2 are both pointing to the same address, right? So what's going on is here, I allocated name 1, and here I freed name 1. Here I allocate a variable called name 2. But in C, when you free something, you are supposed to set it to null, so it can't be used anymore. If you free it and forget to null it, then you can print what's in name 1 later. You can still read and write to that address using the old name, and that means you're reading and writing on top of data that's being reused for another purpose. It's another form of memory corruption. It doesn't happen in Rust because you allocate it here, and if you try to use it down here with name 1, it will tell you, you can't use name 1 because it's out of scope. So you can't make this mistake. It automatically frees it when you pass the scope, and when you try to refer to it later, it will stop and give you an error message saying, no, you can't use name 1 anymore. Name 1 only existed up here, which is what you want. You want a program to warn you when you're making a mistake instead of just blithely doing the wrong thing the way C does. So that's the point of that. And I think I then had some other ones here. I think I had a actual duplicate pointers where you can have 2 pointers pointing to the same address and showing how that works. And I think I had another one where you actually do a command injection. But anyway, it's a good thing to see these things and compare the memory corruption problems in C. Rust does not end all security problems, but it does end memory corruption problems, which are by far the most common, most serious errors in C. And that's why all current development projects are moving more and more of their critical code to Rust. All right.